Thanks, everyone. Good morning. My name is Charles. I'm a software engineer at Audible, and today I'll talk to you about Swift command line tools. So outside of Audible, I also maintain a tool called XCBeautify, and so today I'll teach you some of the learnings I had from that and how you can set up your own tool as well. So just to get started, who here has ever written a Swift script? All right, a lot of hands. Who did not know you can script in Swift? Okay, this is good. Who has written a Swift script? All right, so there's still a lot of people. And who's written a shell script? All right. I won't ask how many of us like shell scripting. But if you look at this example, you can see that it's kind of unclear what this even does at first glance. I'll let everyone kind of guess on their own, but for the curious, this prints the second and fourth columns of the CSV file. But the point is to say that when you look at this code, you might find it unfamiliar like I do. There's quite verbose syntax, and it's not what I am often used to day-to-day scripting or writing in Swift. And so the thought is, how could we leverage Swift to write scripts too? And so let's first understand why we might want to do that. So the first is the type safety of Swift. Obviously, with shell scripting, we lose out on that. And oftentimes, I'll find that I'm spending more time debugging my script than just doing what I wanted to do. We can also leverage some of the modern features of Swift, things like async await, which we've heard from at this conference. And the last is the familiarity. Obviously, we're all writing in Swift day to day, and so by using the same code, we can just focus on the task at hand. Swift is also used in quite a few popular CLI tools that you use today: SPM, Swift format, and Xcodes as well. So let's get started. We're going to leverage the input and output functionality of the Swift standard library. And so we'll just start with what we all know: print. You can define a simple file. Here, I'm just printing out the date and just a simple message with it. And you can see with just this top-level code, if I call Swift and the file name, I can simply execute that code. Now, I can do the same to read input. When I want something a little bit more complicated that maybe accepts user input, I can use this type called command line. And I can then leverage the property called arguments, which is an array of strings of that input. And so looking at this slightly more complicated example, you can see here that we now call the command line arguments property. First, validating that there's the correct amount of input, and then accessing that first input for the name. And so here, you can also see that I'm able to leverage exit, which is a functionality that's within the foundation library, which allows me to signal errors when maybe things have failed, such as invalid input. And so when I call that from the command line without the input, you can see here that it's failed, giving a message to the user and also exiting with failure. And then when I call it again with that input, we've accessed it through that command line type, and it's outputted to the console. We can do the same with standard input. So for instance, if you have a file, or for instance, you wanted to get user input through the execution of your command, you can call this method called readLine. And so as an example here, you can see this bit of code, which calls that readLine method here. So you can see it's kind of at the middle of the execution. And so when I call it from terminal, my command will stop, waiting for the user to actually enter their input. And so in this case, after I enter my name, it will continue on and exit success. Now similarly, if you don't wish to actually require explicit user input, you can read environment variables just as we do with shell scripts. And so you do this with a type called process_info. This is a dictionary of string and string, where you can then access it in a very similar syntax. In this example, we're accessing an API key. And so for this example, you can potentially have different configurations. You can imagine like a debug and a production version of your tool. We can do the same with writing to standard error. And so before, I showed you the example of print. But there's a different variation of print which accepts a type conforming to text output stream. So to actually use this example, you can see how we define this custom type called standard error output stream. This type then actually writes data to standard error and allows us to potentially filter output that a user might want to send to both standard out and standard error separately. And so in this example, you can see how it's quite clean to do that in your code. Similarly to writing to standard error, you can write to a file. And so we'll use a similar method called write. Here you can see it accepts a URL and some other parameters, and you can simply call that command quite cleanly. Now, you saw earlier that when we want to execute all of these files, we can call them with the Swift command. You enter the file name as its input, but you can find that this might often be a little bit even verbose. So similar to shell scripts, we can chmod and make the file executable. Once you do this, you can simply call the command like so. But we can take this a step further. If we want to introduce portability and specify explicitly that it's a Swift file, you can add a hashbang to the top of your file, similar to what we might do with bash. You can rename the file, dropping the Swift extension, and then you can just call your command like this. Now, you can even take this a step further, moving it so that this way you can simply call it as Pragma, similar to what we might do with git commands or SPM commands. Now, I've shown you quite a simple example here where we're just using files, but we can take this a step further to now define our tool as a Swift package. You can do that by first initializing a Swift package as an executable type. And so when we do this, you can also do this through the GUI. And when we do this, you find that we end up with two files similar to any other Swift package. Taking a closer look, you'll see that we start with a package manifest file, and we also have a main file. That main file, in this example, is just top-level code as I showed before. And so, as I mentioned, this file called main is actually a special keyword for Swift CLIs. So taking a look at this definition here, you can define the entry point of your CLI in one of two ways. The first is you can define the file as main.swift. This is, again, a special name that the executable will know to use as the entry point. Or when you start building something more complicated, you can define it as the @main type, and that will then define the entry point instead of the file name. So once we're all set up, you can simply call Swift run. Again, if you're in Xcode, though, you can actually leverage some of the tools right there. And so in this case, you see that when I click the run button, down in the console, we see our hello world outputted with exit success. Now, let's go back to an earlier example where we defined command input. You can see here it's the same one where we've defined two input parameters, accessing the first name and printing it out. But when you call this code, you'll notice that, again, we're expecting two inputs. So how can we actually tell Xcode to take that input that we want? And we can do that in the scheme editor. You might not have seen this before, but there's a section called arguments. And in this section, we can pass both arguments and environment variables, allowing us to access them in both ways we saw earlier. And so in this case, I'm going to add my name as the explicit input. And when I call this code again, you can see that it's accessed it as the input variable. So just taking a high-level look at what we've seen so far, you'll notice we're in a familiar environment, using Xcode and allowing us to use the tools that we're used to. Because we're in Xcode, we could potentially unit test. We'll talk about that later. But because we're in the context of a Swift package, we can now leverage the dependencies of the ecosystem to build something a little bit more complicated. And in this case, we're going to talk about potentially the most popular one to use, which is Swift Argument Parser. This is an open source tool that's written by Apple, and its intent is to allow you to easily define complicated Swift CLIs, but to get started very quickly and easily. So we're going to go through just some of the examples of how you can get started. The first is with commands. So the first command is a parsable command. This is synchronous code, and you can see here that simply with this example, we will print hello world. You'll notice that I'm using the main attribute here, and so this is the entry point of our app. But when we want to work in an async environment, we can leverage a different command called an async parsable command. This allows us to annotate our method with async, and you can see that right out of the box, this code will simply run and understands the context that we're in. Like I said before, we've defined our type as main, and so just switching our default type allows us very easily to do that. If you want to start building a more complicated tool, you might find yourself having different commands that you want to define. And so you can think of this as an example with git, for example, where there are different commands like git add, git push. And so in those cases, having different commands allows you to have very focused ones, allowing for some modular code, scalable when we want to add or remove ones, and it gives clarity to your users to understand what that command is actually going to do. And so in this example, you can see we have a greet and farewell definitions. And so now we run into the issue of having to define the entry point of our app. Which one is app main, and how do we access the other? And so we do this with a command configuration. In this case, I've defined a command called myTool, and we have two subcommands, greet and farewell. Once we define this, we can define the entry point of our app. So if someone were to call myTool from the command line, it will automatically invoke the greet command. Now, once you start wanting to introduce user input, we can leverage some property wrappers to do that. So the first is an argument. This is simply a positional argument. And so when you call your command from terminal like this, you can see that the first input corresponds to the source. Similarly, if you want to introduce an option, so rather than a positional argument, a named argument, you can define it as a variable, and you can invoke it simply with the same name as the variable. If we want to define a flag, so you can think of this as like a quiet or verbose flag that we often see with other commands, you can do that with the flag property wrapper. As you start introducing some more complicated tools, though, you might want to customize the actual interaction with it. And so we can do this by annotating our flags and options with different parameter values, similar to other property wrappers. And so here, you can see we have both flags and options, which define an explicit name. Rather than using the actual variable name, we've defined different ones using long, short, and custom values. So in the case of verbose, you can see the short one uses simply -v, or you can define custom ones that don't even match the name of your variable. So going back, you can also define some default values. And so for example, if you want to give your users a better out-of-the-box experience, you can give them those default configurations, allowing them to override it only if they need to. Now, if you want to start defining custom types which your users can use, we can use, for instance, enumerable flag. In this case, we're defining file formats, and if a user invokes your command, they can pass those file formats simply as flags to actually specify to the tool which ones to use. And you can see how passing multiple flags very cleanly sets itself into the formats array. Similarly, there's expressible by argument. So if, again, we want those explicit inputs, you can specify a format variable here, calling then a custom type with the expressible by argument protocol. Now, with your tool, you are going to expect certain input. And so to actually verify that a user has done that, you can leverage some of the default validation logic that the tool gives us. With this, we can centralize the logic into one place, giving user feedback before we potentially move further in the execution of the tool, and executing as the first step of it. And so here, you can see how there's now a new method called validate. This overwrites the default empty implementation, checking that a number here is greater than 0, and throwing an error in the case that it doesn't satisfy the condition. This method then will run before the run, which you see below. Now, you saw earlier how we can leverage that out-of-the-box exit command, but the Swift argument parser will give us some more that we can leverage. So there are 3 specifically. One is a validation error. So if a user provides invalid input, we can throw this error, allowing the user to have a very clean message understanding why we stopped execution. You can define a custom exit code, giving your users maybe a more custom error later on in the execution of the tool, or we can exit cleanly if everything has finished successfully. And so in this case, we're throwing that validation error with a custom message. And you can see here, when we potentially execute the tool improperly, that even within Xcode, we see that error and the exit code which corresponded. Now, as you define a more complicated tool, you're going to want to give your users context to understand how to use it. And so we can first do that with that command configuration we saw earlier. You can first define an abstract of your tool, giving your users a high-level summary of what your tool does. You can then, in the discussion, define in more detail how to use it and potentially an example. And also here, defining the version which a user is using so they understand potentially if they're out of date or just which version they're on. Similarly, with your input, you can define the help parameters so they understand what the intent of each input is. What's nice is that Swift argument parser gives us this help flag. And so when we invoke it, we find that it gives us this nice out-of-the-box output. It's cleanly written with the abstract, the details, and all of the input parameters which are available to the user, allowing them to understand at a high level how to use your tool. Now, when it comes to unit testing, this is a joke. We all know that unit testing might often be a second thought. But the reality is that now that we're in the context of a Swift package, we can leverage things like modularization, allowing us to actually separate out our business logic from the executable, and also leveraging some of the parse methods so that we can actually invoke different variations of the tool, seeing how it behaves when we call it. Now, as we're actually outputting messages to our users in the console, we might want to give them something a little bit more readable. And we can do that with ANSI escape codes. I won't go too much into details what they are, but they allow you to actually style the output of your strings. And so in these 3 examples, you can see how we've changed strings to a different color, added an underline, or made them bold. And so you can see in this example where we potentially have verbose output, that simply adding those different styling to the strings allows us to draw the user's attention where necessary. There's a quite good tool which I use called Colorizer, but there are others. In this case, you can see how in quite clean syntax we can actually style our strings. Again, going to those examples, making them red, bold, underline, etc. Similarly, we might want to build context-aware CLIs. So when I first got introduced to XCBeautify, I started with a feature to build GitHub Actions annotations. Just by raise of hands, does anybody use GitHub here? Yeah? Okay, great. So GitHub Actions annotations allow you to actually add inline and summary output to some of your pull request jobs. And so what that allows you to do is specify to your consumers maybe important messages, warnings, and errors. And similar to the ANSI escape codes, you do this by prefixing your strings with error, warning, and notice. I should note that this is specific to GitHub, but other CI providers have similar formats where you can do this for theirs as well. Going back to our example about flags, in this case, we know that isCI will be true while executing in the context of GitHub. So we're able to define a default isCI value, again allowing a user to overwrite it if they wish. In this case, we can now prefix our message with those error and warning strings. And what's nice is if we run this tool, for example, in GitHub, we can now see that our output is actually in line. In this case, this is XCBeautify defining a failed test. Similarly, in GitHub, you can see how this will actually show up in the summary view now, allowing our users to see it in a different context that's more helpful. So to just wrap up, let's talk about how you can level up your tool. I mentioned before how we're in the context of a Swift package, and so we can leverage some of the out-of-the-box tools which others have made. The first is this tool called Visual Indicators. This allows you to define your CLI in more of a Swift UI-like syntax. And so here you can see how it's a little bit more enjoyable to actually invoke the tool, allowing us to navigate in a more visual manner. Now, if you define your code, which then actually needs to invoke a shell script, we can leverage a tool by John Sindel called shell out. Here you can see how within Swift code, we can actually invoke our shell commands when we need to. If you've worked with the file system, you know it can be a bit of a challenge. And so here we have a tool called path, in this case allowing us to do things like making a directory, navigating to a file path, and even changing its permissions. And lastly, if you've ever worked with a tool that maybe has some configurability, you might want to introduce a YAML file. In this case, there's one called yams, and it allows you to define that YAML file in Swift in similar syntax, allowing you to read, similar to JSON decoder, the configuration file which a user has defined. Just like shell scripts, you can pipe output using that readline method we saw earlier. So in this case, this is how XCBeautify works, using the read line from the Xcode build output on the command line. We can also share our logic. Like I said earlier, we're in the context of a Swift package. So you can imagine how you might modularize your code where the business logic lives in a central package, your app consumes it, and your CLI does this as well. A great example might be an app which maybe uploads or downloads content. You can imagine how, rather than having to go through your app and having to upload or download content, you might use your CLI to do that in batch. Once you've completed your tool, we can invoke a command we can invoke the Swift build command in the release configuration, allowing us to productionize what we've built. If you wish to share this with others, I recommend using GitHub releases. In this case, you can see how we've defined cross-platform variations of XCBeautify available for both macOS and Linux. And then later, if you wish to distribute your tool, you can leverage things like Homebrew, allowing you to define a formula where a user doesn't actually need to understand the contents of this, but rather is able to quickly and easily download your tool simply with commands like brew install. So just some closing thoughts. I've talked a lot about Swift today, and I've kind of advocated for its use, but remember that Swift is only an option. If shell suffices, use shell. But as you need something more complicated, we can start leveraging Swift to first define a file, use the code that we need, and only once we need something slightly more complicated, start leveraging Swift packages. Once you start needing to build on top of that, we can leverage things like Swift argument parser, as I mentioned, defining a more complicated CLI that others might then eventually use too. If you're interested in learning more about the argument parser, Swift and Apple have some great documentation which you can go through, talking about much of what I've said today. And with that, thank you.
Thank you very much, Charles. We now have some time for some questions. Hands up. One up here.
I have a tiny question. First of all, thanks for making a talk finally about this, because I've looked at this thing and every time I kind of gave up because, anyways, so it's great. I wonder, when you specify parameters, there's the short and the long version. Is it by default that it will allow you to use both short and long, short being the first letter?
So by default, it uses the long value, so it matches the name of the variable. And then you can specify an array of different configurations. So if you want to define both the short and long version, you can specify both. You can use either the default first letter or long name, or you can define custom ones for each.
But you have to specifically say, I want to, it's opt-in, basically.
Correct.
Okay, cool. Thanks.
Yep.
Do we have more questions? Yes, one up here.
Hello. So you've said that we should use Swift argument parser only for more complicated CLIs. But what are actually the disadvantages of using Swift argument parser, which doesn't seem to have a big of an impact on my app's performance or even of its size? So, for instance, if I have an app which needs to have some validation logic, needs to have some options and arguments, can I use Swift argument parser just like this, or I should think twice before I do it?
So if you're defining a CLI, Swift argument parser is an option for it. I like it because it allows you to have all of that default validation, input definitions. I'm not sure that there's necessarily disadvantages other than it might be more than necessary. And so as I had mentioned earlier, if, for instance, you're defining a simple script, it might be easier to just do that with the command line type I talked about earlier.
All right, thank you. I understand.
Yes, there's one in the back, all the way down there.
Hello. I was just wondering if there is any issue with Linux compatibility of the command line tools. So, for example, I recently developed a tool that works on the command line, but just on macOS, and I was looking to do the porting to Linux, but I encountered some issues, especially with all the libraries, the external libraries that are imported with the command line tool. So I'm just wondering if you ever tried to make like a sort of porting of a tool that runs also on Linux.
Yeah, so I think I had shown an example earlier about XCBeautify, which does compile for both macOS and Linux. And so it is nice that this command line tools are portable on both. That said, you do run into situations in which certain APIs are unavailable. And so the way that I do that, for example, with XCBeautify is simply with the if definitions, checking if the OS or if a feature is available to Linux. And if not, I compile it out. You can, for example, do that if you have GitHub check set up to define the platform destination. And so you can actually compile both configurations to make sure it remains compatible.
Good. Well, thank you, Charles.
Great. Thanks so much.